Okay, we're going to be looking at graphs of functions and finding out the intervals where the graphs are increasing, decreasing, and constant. And a couple of things to remember here is that you always read your graph from left to right. And if you are not given a graph, but you're just given an equation, then stick the equation in your calculator and graph it. Okay, here's problem number 1. One of the first things I want to point out here is that notice my line of my graph does not go all the way to the edge of the grid. So that means my graph actually stops at those points. Remember I told you in a previous video that if your graph goes to the edge of the grid, it's assumed that it's going to continue on forever. Since my graph stops at this point and at this point, I know that my graph does not go on forever. Okay, first thing I'm going to do is eliminate these numbers here on the y-axis. My intervals are all about the numbers on the x-axis. Okay, I'm going to start as far left as I can and just follow the graph. And as you can see here, I'm going down, so that is decreasing. I'm going to highlight that pink. I'm going to highlight that pink, and I'm also going to highlight this part of the x-axis pink as well, so I can see that they match up. The next part of the graph I can see does not go up or down, so that's constant. So I'm going to highlight that green. This next part of the graph is going down, so I'm going to highlight that pink. And I'm going to highlight this section down here pink as well. The next part of the graph is going up. That's increasing. So I'm going to highlight that yellow. So I'm going to highlight this section of the x-axis yellow. Next part of the graph is decreasing. So I'm going to highlight that pink and I'll highlight this x-axis pink. And from this point, I'm going up. And once I get to here, the shape of my graph changes, but I'm still going up. So all of this part of the graph is increasing. So now the only thing I have left to do is to write in my intervals here. So again, reading from left to right, the yellow part is from -2 to 1. Then I skip this pink section and then I union that with the interval from 4 to 9. Okay, now we're going to identify the intervals where my graph is decreasing, and that's the pink part of my graph. So again, reading from left to right, I'm going from -10 to -8. I skip over the green part, and then I union that with -5 to -2. And then I skip over this yellow part, and then I union this with 1 to 4. And the interval that's constant, that's highlighted in green, is from -8 to -5. Okay, with problem 2, what I want you to notice is that I have arrows here on the ends of my graph, so they do indicate that my graph is going to go on forever. And like last problem, I'm going to be highlighting the increasing part of my graph in yellow. I'm going to be highlighting the decreasing part in pink and the constant part in green. And I'm going to get rid of these numbers here. I don't want to be looking at those numbers. Now I want to start with the leftmost part of the graph, so over here. And it's very tempting to want to follow that arrow down, but remember we're reading our graph from left to right. I'm actually going up here. So this part of the graph is increasing, and I see that this part of the graph is increasing as well. So my interval notation here is from -infinity to -5, and union that with this part of the graph, that's from 6 to +infinity. Okay, now the decreasing part is going to be highlighted in pink, and I can see it's this part of my graph here. So I'm looking for these numbers on my x-axis, and that is from 1 to 6. And then the constant part of the graph is this section right in here from -5 to 1. You're going to start at the leftmost part of your graph. And as you move along the graph toward the right, you can see that you're increasing. So I'm going to highlight that yellow. And then I'm also going to highlight that section of the x-axis yellow. Now, as we continue along here on our graph, you can see I'm going down. So I'm decreasing, highlighting that pink. The interval where my graph is increasing is from -infinity to -2. The part of the graph where it's decreasing is from -2 to +infinity. And the part where it's constant, well, there are no intervals where it's constant. It shows none. Okay, problem 4. We're going to start at the leftmost part of the graph, which is up here. But notice that it actually goes to the edge of the graph, which really means that this graph is going on forever. As I read the graph from left to right, I can see that it's decreasing. So I'm going to highlight this section of the x-axis pink. And then once I get down to this vertex, I start increasing. So I'm going to highlight that yellow. The part that's increasing is from -1 to infinity. Remember that we're reading along the x-axis here. The part that's decreasing is from -infinity to -1, and the interval where it's constant, there is none. Okay, problem 5. You see I have a quadratic here, but I don't have the graph. So what I need to do is make a quick sketch of that. I can either do that just from what I've learned about graphing, or I can stick this in my graphing calculator. This is going to be a parabola that opens up. And I am interested in this vertex. Well, to find the x-coordinate of the vertex, that is -b over 2a, or the opposite of b over 2a. So the opposite of -4 is +4 over 2 times 2. So that's 1. So this is the point 1 something. I don't really care what that y value is. When I'm reading my graph, I'm starting at the left and then I'm going down. So I can see that my graph is decreasing here. And once I get to that vertex, then my graph starts going up. It's increasing. So it's increasing from 1 to infinity. It's decreasing from -infinity to 1. And there's not any part of the graph that has a constant value. All right, problem 6. This problem tends to be one of the problems that students miss a lot. And it's because we've been working with parabolas so much, we forget to actually stop and look at the equation a little bit more closely. This is a linear equation. My exponent here is 1. So this is linear. I know the slope is 3. So the graph of that function looks like this. That is always increasing. So it's increasing from -infinity to +infinity. Nowhere is it decreasing and nowhere is it constant.